Okay, in 14.0 and 14.1, we've been studying patterns in the sky, specifically sunrise and sunset, and focusing mostly on that 24-hour, that daytime. Now we're going to look at sunrise and sunset over a year. So patterns with the sun over a year. Okay, you're going to be using a simulation that is like the one you saw before. It's a video of somebody doing a computer simulation that is filmed in Kansas. It's the same one that you watched beginning, but it has more details. Okay? And as you watch these different simulations, you're going to collect data 3 months at a time. Your tasks are going to look like this. Okay, you're going to collect. So this slide will be the video simulation from January to March. So you're going to collect January, February, and March. You're going to be collecting the sun's height and the hours of sunlight, which is sunrise and sunset. So I'm going to show you how you're going to do that. Okay, and I'm going to show you what it looks like. When you're done collecting that data, then you're going to make a summary statement using the words increasing and decreasing and the months. So from January to March, the sun's height is increasing, decreasing, and the hours of sunlight are increasing, decreasing. Spoiler alert, it's going to be one of those. Okay? So after you collect the data, you're going to look at what's happening. Is it getting bigger? Is it getting smaller? And you're going to make that. Once you do January to March, you're going to do the next 3 months and so on. But let me show you what that simulation looks like and how you're going to do that. So this is the intro video that I'm going to show you, but also kind of skip some parts because this is the intro video, but it's going to be very similar to the others.
This video was made using a computer program called Stellarium. This is an introduction video that will show you what you can see and the different kinds of information you can learn about how the sun moves in the sky from watching these simulation videos.
Okay, so you're going to see like the sun rising in the east, right? She's going to give you a quick tour of
field in the middle of the United States. South, W for west, and as I turn around you can see N for north and E for east. You can see it looks like the sun is getting ready to rise in the east.
Okay, so she's giving you just a tour of what the program can do, but you're going to be watching the whole video of it, right? So you could do a whole 360, look at it if you were in this program, okay? And then she's going to watch the sunrise and set in the east.
In Kansas.
And it's in Kansas.
Tell you it is morning. So, what we can do with this simulation is actually watch what the sun does throughout an entire day, but in only a matter of minutes. So I'm going to actually turn time on and let it flow through time. You could start to actually see. And I'm going to speed time up so we can watch entire hours pass.
Okay. I'm going to zoom this out. She points this out. I'm going to point it out to try to make it faster. You're going to collect the sunrise time. Okay, and the sunrise time is 7:02. If you can see here, down here in the bottom right hand corner, right? That says 7:02. That's 7:02 in the morning. It's in Kansas, it's Central Time. Okay, 7:02 in the morning. That you're going to record as your sunrise time.
Speed time up so we can watch.
I'm going to speed it up even more.
And you can see I'm turning to look in the southern sky so that I can always keep a view of the sun right up there in the middle of the sky. And as it goes down, it starts to set towards the western sky later in the afternoon and evening. And I'm going to try to actually stop and freeze time when we get to sunset, which is about now. So you can see that the sun is setting.
Okay, its sun is setting. It's 18:55. This is military time, which means it doesn't use two 12-hour cycles. It uses a 24-hour cycle. So the sunset time is going to be 1855.
And it is in the west. And you got to view an entire day in only a matter of seconds. So now we're going to...
So I'm going to go to what that looks like in your chart and tell you how to figure it out. And then we'll come back to the video. So you would write this. She's not actually watching January, but imagine you were watching January. You would write January, or the month that it was in. I think hers was in September, but January. Skip the sunset for now. The sunrise, you're going to write at 7:02. The sunset, you're going to write at 1855. Right? Now, what does that mean? It would be lovely if I could just take 1855 and subtract 7:02. But I can't because they're not actually decimals and they're not in base 10. Right? So I have to figure out how many hours and how many minutes. I can actually take the largest number and subtract the smallest number. I just have to do them separately. So I can do 18 minus 7 and I get 11. Okay? But just to show you what that means, because it feels a little weird. If I start at 7 on my 24-hour clock and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it's 11 hours. 11 hours have passed between 7 a.m. and 18. You don't have to say a.m. when it's military time. Between hour 7 and hour 18. Okay? I can do the same for the minutes. So that's my 11 hours. I can do the same for the minutes. Okay? I can take 55 minutes, which is right here. These go by fives. 55 minutes. And say how many until 2. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. This would be 55, but it was 2, so it's 53. I can also take 55 and subtract 2 and get 53. Okay, so I get 11 hours and 53 minutes. I just can't deal with them as a whole. And I always take the bigger number because of the way I'm dealing with just the difference between them. It's actually what you're learning is absolute value. Just the value between the two numbers, right? But don't worry about that. Just find the difference between these two numbers and the difference between those two numbers. You'll have this in slides to help you if you want to count. But then you're going to record. You're going to record how many. So let's say this is January. It's not. So your January is going to be different. Okay? But let's say it's January. It's 7:02, 1855. Sunlight. 11 hours, 15 minutes. That's how you're going to record that. Okay? Now let's go back and watch for height in the sky. Nope. Sorry.
Right up there in the middle of the 2. I'm going to turn on a special line that's kind of like a protractor in the sky. It allows us to measure, like a ruler, the height of the sun. There is this line here that goes from south all the way above us and around to the northern side. It cuts the sky in half. But it has these measure markings on it. You could see 30, even here we have 20, 10, and if we keep going up it goes 40, 50 degrees, 60 degrees, and right straight above you is always 90, just like a protractor. So here's what we're going to do. We're going to watch, go back to the morning, and watch the sunrise, go through time again, direction here, and then I'm going to pause it right when it passes the meridian at noon.
So now we're going to measure the height of the sky.
And here goes. Look at that. The sun is about how high in the sky. Take a moment and measure.
So this is 60. Right down here is 30. Look at the 40 and the 50. The 50 is right here and slightly above 50.
What did you think? If you say 30, 40, 50, and a little over 51 degrees high in the sky.
So that's how you find the height, and the video will walk you through it, right? But then you come back to this one, and you say 51. It's degrees if you're looking for the label, but you can just put 51. The height is 51. You're going to collect this data. You're going to do it for the whole year, but in chunks of 3 months, so we can watch patterns. Okay? So that is tasks. That's how you do it. Tasks will have one of these charts, and then January to March, and then you'll fill out this summary after you've done January, February, March. Then you'll go to the next 3 months, etc., etc., etc. Okay? Good luck. Have fun. This takes a little practice, but once you get into it, you'll be able to go through it. Okay? All right.